Welcome back. This time we're going to look at the segment addition postulate and how it can be used in a proof. Okay, so I'm going to try to prove that given A is between R and M, and the value of RA equals 7, AM equals 5, and RM equals 6A plus 24, I'm trying to prove that the distance from A to M is 20. They didn't give me a picture, and it is always helpful if I can draw myself a picture in geometry. So I'm going to do that. My given A is between R and M. So A is between R and M, so my endpoints are R and M. And A is somewhere on that line. I'm not going to put it right in the middle, because that way in the future I won't get confused once we start working with points that are in the middle. So I'm going to offset it a little bit. A. All right. Then my next given statement says R to A is 7A. So from R to A is 7A. From A to M is 5A. And from R to M is 6A plus 24. Okay. So now that I have my picture drawn, I can start my proof. So let's set up our two columns. We have our math, our statements on the left, and we have our reasons, our justifications on the right. Now I have lots of givens here, right? My first one is given A is between R and M. So I'm going to start with my first one. A is between R and M. Given. Now at this point I can go on and I can write my other givens, but I'm going to hold off because as soon as I know I have a point between two other points, I can go back to my notes and I can remember that once I know I have a point between two other points, I know with the segment addition postulate that the two smaller pieces equal the bigger one. So for my segment addition postulate, once I have one point between the other two, I can apply this rule. So I do have A between these 2 points, so I'm going to apply the segment addition postulate. I know once A is in between, I know RA plus AM equals the whole thing RM. And this equation might be difficult to come up with if we hadn't have drawn the picture and we could see the RA and the AM are my two smaller segments that make up the whole RM. Okay? And then I don't put given here. We got it because we were given this, but we're using the segment addition postulate. Okay? So now I'm going to go to my next given. So my next given is RA equals 7A. So I'm going to put a little check because I'm going to write it down. RA equals 7A. And remember, the capital A's and the lowercase a's, those are super important to pay attention because the lowercase a is going to represent the variable and the capital A represents the point in the diagram. Okay? Now, at this point, I could come and do substitution, right? Because RA equals 7A, I could substitute it in right here. But since I can also look ahead and see I'm going to also want to be substituting in AM, and I'm going to want to be substituting in RM, I'm going to write my other two givens so I can do all my substitution at one time. AM equals 5A. Let's write this one down. AM equals 5A. And then RM equals 6A plus 24. So RM equals 6A plus 24. And we could really have written all three of these on the same line with commas in between, kind of like how they're written here, comma, comma, and this one. And then just written one word given. That would have been just fine also. Okay? Or you can do it as three separate lines and have a reason for each one. Either way is okay. All right, now we're ready to substitute our values in. Okay, so we're going to substitute in to this equation right here. RA, I'm going to replace with 7A. AM, so then plus, I almost forgot my plus sign. AM can be substituted with 5A. Equals RM can be substituted with 6A plus 24. And all we did was we took these three values and we substituted them into this equation. So it's the substitution property of equality. Okay? All right, so let's look at what we're going to do next. The next thing I'm going to do is I'm going to look for some like terms, right? Because now we're just a basic algebra. I have a 7A and a 5A, so I'm going to put those two together. My 7A plus my 5A is 12A, good, equals 6A plus 24. So to get from here to here, I just combined my 7A and my 5A. It was addition, but it only affected one side of my equation. The right-hand side's not changed. So this is combine like terms, because all we did was put these two together. Okay? All right, so now I want to get all my A's together. So I'm going to move this 6A to the other side by subtracting it. Move my smaller variable. So 12A minus 6A is 6A equals 24. And we subtracted on both sides, so that's my subtraction property of equality. And remember, if you're abbreviating, you have to get me at least to the ST for substitution and the TR for subtraction. All right, we're almost there. We just need to divide by 6, right? So I'm going to divide both sides by 6. So 6 over 6 is 1A, and 24 divided by 6 is 4. So A equals 4. We divided on both sides. Division, property of equality. Now let's see, we're done, right? That's what I was trying to prove. I was trying to prove that x equals, oh wait, that's not what I was trying to prove. Look what I was trying to prove. I was trying to prove that AM equals 20, but AM equals 5A. Wait, now I know what A equals, right? A equals 4. So if I take this AM equals 5A, I can substitute in the 4. Right? So AM equals 5, substitute in the 4. Substitution, property of equality. And then now we just have to simplify the 5 times 4. So AM equals 5 times 4 is 20. And all we did was simplify. Okay, so that is a geometric proof using the segment addition postulate. Thank you for watching.